Greetings everyone. My name is Vivendran Krishna Kumar and today we will present our signal system project for the course BERT 2423. This project demonstrates several signals processing techniques using MATLAB. So for the first task, we record our own voice and save it as a WAV file. This voice signal was used as the input signal for our experiment. So these are the observation and the problem we faced during our task 1. The original voice signal was clear and easy to recognize. After convolution, a delay repetition could be heard clearly. We observed that a high factor alpha produced a stronger echo while a lower alpha gave a weaker echo. So this is the code we use for our task 1 in MATLAB. We actually changed a certain line from the code so we can get a better view for our voice message signal. So this is the output we got for task 1. The output signal duration increased due to the convolution. Normalization was required to avoid distortion and clipping. So this is the discussion and conclusion we got from task 1. For discussion, convolution effectively applied the chosen impulse response, which is echo to the recorded voice. The echo effect clearly demonstrates how an audio signal can be modified using system impulse response. Normalizing signals was important to maintain the sound quality and avoid clipping, as I told in the discussion before this slide. For conclusion, convolution effectively demonstrates how audio signal can be modified using impulse response. This concept is widely used in audio processing and communication system.
Okay, my name is Muhammad Shamil bin Ismail. My metric number is B122410090. Okay, I'm going to present on task 2, the Fourier series. Okay, for the Fourier series, the task focus on Fourier series and Fourier synthesis. And the objective was to compose a 10-second song using only sinusoidal harmonics. Okay, the first condition is in compose a song with a duration of 10 seconds and manipulate the MATLAB code provided in the figure 1 to generate the my own code. Okay, as you can see, this is the code. Okay, for the second condition, during the demonstration, play all the harmony and complete the song. Okay, so this is the second condition. Okay, for the third, you are also required to display, and so for this display, I use this code. Okay, moving on to the output and sine wave. The difference between harmonics were used to generate bass, lead, kick, snare, and melody. Each frequency was played and plotted individually to show its contribution to the final song. Okay, so as you can see, the difference between of the frequency. Okay, moving on to the last discussion and conclusion. The slow motion bass created a hypnotic effect, while the kick and snare added rhythm. Soft clipping was applied to prevent distortion too. Overall, this task shows that the complete music can be created using only sine wave. Okay, that's all from me. Thank you.
Hello, Assalamualaikum. I'm Muhammad Aslam bin Khalid. So I'm going to explain the task 3 for our project. So the task 3 is to snap a photo of our team member in our best pose and visualize it in our original image into frequency domain using fast Fourier transform. Then reconstruct the image back to spatial transform. So for the coding, as they show below, this is our coding for our group project. So here is the result from the coding after they execute. Here is before and this is after. So the after execute, we get the original grayscale and reconstructed. So for our discussion in task 3 is we successfully captured a team photo and load it into our MATLAB as the original image and converting the image grayscale simplify the processing while keeping the action in detail by applying 2D FFT fast Fourier transform and transform the image from the spectral domain to the frequency domain, showing the how image information is distributed in terms of frequency. So the magnetic spectrum reveal that low frequency component, the sector of spectrum, represents smooth area like skin and background. So high frequency component is edge and corners, represent that detail like hair, nose and facial feature. By using the inverse fast Fourier transform, we reconstruct the image back to spectral domain and closely resemble the original one. So from this experiment, we demonstrate the frequency domain contain all the information needed to recreate the original image. So by visualize the fast Fourier transform, it helps understand the application the image to compression, filtering, and enhancement. So for our conclusion, the fast Fourier transform is a powerful tool for analyzing the image in the frequency domain. The image reconstruction using inverse fast Fourier transform confirm that the information is lost if all frequencies are preserved. Frequency domain analysis allow us to identify pattern, edge, and texture that are not always in spectral image. By the understanding the fast Fourier transform is important in real-world applications such as signal processing, medical imaging, and multimedia technologies. Overall, this task is enhance our understanding of how image can be represented, analyzed, and reconstructed mathematically. So for the task 4, I'm gonna go to the Aiman. Thank you.
Okay, hello, Assalamualaikum. My name is Aiman Hakim, course BRC section 11, number matrix B122410649. And thank you very much for Aslam for the explanation. So right now we are going to continue our slide 13, which is introduction for task 4. And for task 4, we apply Gaussian filtering to smooth the image and reduce noise. This filter uses a Gaussian function, and the amount of smoothing depends on the sigma, the value. And here's the code that we made. And so this slide show the MATLAB code used to apply Gaussian filtering. And here we are define the Gaussian kernel and specify this sigma value. So we put the number for maybe 10, 7, 2, 5, and we are going to show you the output itself. The image is then going to convolve with the Gaussian filter to perform a smoothing. So now here's the result and output, and here's we label the sigma 2 equals to 2, and then the smoothing image is sigma for 5. This output shows the result with a higher sigma value. The image become much blurred, which reduces the noise but also removes the fine details. Okay, and this slide represent much more even blurred lah. Sigma equals to 7 and sigma equals to 10. And then here are the slide represent the MATLAB code for Laplacian of Gaussian filtering. The image is first smoothed using the Gaussian filter, and then the Laplacian operator is applied for the edge detection. Okay, and then here's the output. And with the small sigma value, more edges are detected, as you can see. However, the noise is also detected as the edges. And here's the second output. Third and fourth, sorry. When the largest sigma value is used, noise is reduced, but some edges become much more weaker or disappear because, as you can see, the output is much more darker lah. Okay. And then here's the comes for the discussion and conclusion. Discussion. So we Gaussian filtering smooth the image to reduce noises and sigma value increase. Then the higher sigma value produce stronger blur but reduce image details. Log filtering highlights the edges by detecting latency changes in the image. Smaller sigma values detect more edges but may include noises. Larger sigma values reduce noise but weaken or remove fine edges. So for in conclusion, this project helped us understand how to convolution, Fourier series, FFT and filtering techniques are applied in real-world signal and image processing. Uh, Thank you for your attention.